Right now, at this exact moment, reality is pulling itself apart. Space is actively stretching in all directions. We aren't looking at matter flying through an empty void. The actual fabric of space is growing, driven by a repulsive force we call dark energy. Imagine what would happen if that dark energy simply vanished and cosmic expansion halted entirely. If you were standing outside when it happened, you wouldn't feel a thing. The sun still rises, Earth keeps spinning, and local gravity holds you to the ground exactly as it did yesterday. That quiet normalcy is exactly why a sudden halt is so unsettling. The mechanical foundation of the cosmos has just failed, and down here on the planetary scale, nobody even realizes it. The first people to detect the change wouldn't be looking at the ground. They'd be looking through telescopes at distant galaxies. When astronomers observe those galaxies today, they see their light stretching toward the red end of the spectrum. We call this redshift, and it proves those galaxies are moving away from us. But the moment expansion stops, that redshift hits a wall. The cosmic stretching freezes in place. This breaks a delicate cosmic balance. The universe operates as a continuous tug-of-war between dark energy pushing outward and gravity pulling inward. With the outward push gone, gravity takes total control. Left entirely unchecked, that inward pull forces the universe down one of two inescapable paths. In the first scenario, gravity and mass manage to reach a perfect stalemate. The universe freezes right where it is. Distances stop growing, and the large-scale way-out of galaxies locks into place. On the surface, it sounds stable, but a static universe loses its engine. Without expansion to move energy around and drive cosmic dynamics, the universe begins to starve. Over immense timescales, stars burn through their fuel, age, and die. Galaxies settle. Without energy to forge new light, remaining structures fade out. Stillness eventually reveals itself as a stagnant tomb. The cosmos avoids a violent collapse, but guarantees a quiet fade into freezing darkness. But there is a second, far more violent path. Instead of resting in a stalemate, gravity completely overpowers the paused universe and begins pulling everything backward in a process called the Big Crunch. Distant galaxies that were once drifting away hit the brakes, turn around, and accelerate directly toward us. Over billions of years, the night sky would transform. Instead of fading to black, it grows aggressively bright as millions of returning stars crowd into our field of view. As the universe shrinks, temperatures skyrocket. The cosmos becomes a dense, chaotic environment where massive galactic collisions become the daily norm. Eventually, everything converges. All remaining matter, intense radiation, and kinetic energy are crushed into an increasingly tight volume. At the very end of the line, the entire universe forces itself back into an impossibly hot, dense singularity. Gravity's victory erases every star, planet, and galaxy ever formed, violently returning reality to the exact physical conditions of its birth. That absolute compression might not be a final ending. Many physicists suggest this scenario leads directly to a big bounce. The extreme pressure of the collapse could trigger a second expansion, reorganizing the dense matter and radiation into new generations of stars and galaxies. Fortunately, we don't have to worry about a sudden cosmic reversal. When we return from theory to documented astrophysical data, we see a completely different reality. This chart shows the velocity of cosmic expansion over time. The data reveals an exponential upward curve, proving that galaxies are moving away from each other at an ever-increasing rate. This continuous acceleration keeps us safely out of reach of both a frozen tomb and a fiery collapse. This constant stretching regulates the energy density of the cosmos. It prevents matter from clumping back together into a scorched mass, providing the stable, low-density environment that stars and planets need to persist. It is the very mechanism that allows us to exist, look up at the sky, and ask what happens next.